Alright, so today we're talking rectangles. So you'll be able to recognize and apply properties of rectangles and determine whether parallelograms are in fact rectangles. So a rectangle is a quadrilateral with two sets of parallel congruent sides and four right angles. So essentially it's a parallelogram with at least one right angle, because if it has one right angle, then it has four right angles, as we talked about in 6.2. So if a parallelogram is a rectangle, then its diagonals are congruent. So that would mean lines JL and MK would be congruent. They're going to be the same length. So that's pretty much it. That's how you tell with diagonals, I guess. So these are going to be the same, so they're going to be the same length. You can also tell by the parallel sides and the 90-degree angle, but whatever. We'll stick with diagonals since that's easier. A rectangular garden gate is reinforced with diagonal braces to prevent it from sagging. If JK is 12 feet and LN is 6.5 feet, find KM. So the important thing to know for this question, JK being 12 feet really doesn't matter. The big picture that matters is that LN is 6.5 feet, which if LN's 6.5 feet, then JN is also 6.5 feet, and JL is congruent to KM. Therefore, KM must equal 2 times LN, or not 6, or 13 feet. So essentially, this is 6.5. This is 6.5, which means the whole thing is 13. And we know that JL, that whole piece, and KM, that whole piece, are going to be congruent to each other. All right, so quadrilateral EFGH is a rectangle. If GH is 6 feet and FH is 15 feet, find GJ. So GJ is going to be half of 15 then, because if FH is 15, then GE is 15, which means GJ would be halfway, so it'd be 7.5 feet. Quadrilateral RSTU is a rectangle. If angle RTU, so this little angle here is going to be 8x plus 4, and SUR is going to be, that little angle here is going to be 3x minus 2. We need to find x. Now, we have essentially two types of angles when we're dealing with diagonals in a parallelogram. We have our little angles like PUR, PST, TRU. Drew that the wrong way. So we have our little angles, and then we have our big angles like PTU or SRP, or that one's a little guy, or RSP, or PUT. So the cool thing about these is every single one of these triangles that's made by the diagonals are going to be isosceles triangles. So the two base angles are going to be congruent in each case. And we know if we take one of our little base angles and one of our big base angles and add them together, we're going to get 90 degrees. So that being said, if we had 3x minus 2 plus 6x plus 10, or plus 4, If we add those together, we're going to end up with 9x minus plus 2 equals 90. Then what we're going to do is we're going to solve this for x. So we're going to subtract 2 from both sides. So we're going to have 9x equals 88. Calculator. So we should end up with 88 divided by 9, which is going to be decimal sadness, 9.78. We'll just say x equals 9.78. It's a messy decimal, but it's whatever. Let me double check that. Did I mess up? Yes, I did, because that is... So I said RTU is going to be 6x plus 8. It should be 8x plus 8, which would leave us with 11x plus 2 equals 90, which is going to give us a much better answer. We're going to be 11x equals 88, which would mean x equals 8, which is a much cleaner number. Silly mistakes, they get us all. So, quadrilateral EFGH is a rectangle if the measure of angle FGE is 6x minus 5. So let's get that in there, 6x minus 5. And the measure of angle HFE is 4x minus 5. Find x. So once again, we know these added together will equal 90. So we're left with 10x minus 10 equals 90, which means x equals 10. And there's my redeem question, where I redeem myself for my mistake. All right, so diagonals of a rectangle. If the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. I feel like we've already covered that. So, some artists create their own canvases over wooden frames. This allows them to customize the size of their canvas. In order to ensure that the frame is rectangular, before measuring the canvas, an artist measures the sides and the diagonals of the frame. If AB equals 12, BC equals 35, this is all in inches, I should say as well, CD equals 12, DA equals 35, BD equals 37, and AC equals 37. Explain how the artist can be sure that the frame is rectangular. Well, it's a parallelogram because we have two pairs of congruent sides, and then we also have two diagonals that are the same length of 37 inches, so therefore it is a rectangle. All right, so Max is building a swimming pool in his backyard. He measures the length and width of the pool, so the opposite sides are parallel. He also measures the diagonals of the pool to make sure that they are congruent. How does he know that the measure of each corner is 90 degrees? So he knows that because the diagonals are the same length. Yeah, so they say the diagonals are the same. So RT and SU are the same length, which makes this a rectangle since we have two pairs of parallel sides also. Since opposite sides are parallel, Since opposite sides are congruent, STUR must be a rectangle. Since diagonals of the parallelogram are congruent, STUR must be a rectangle. Delightful. See? All right, so now we're getting into another graphing problem. So quadrilateral JKLM has vertices of blank, 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 and blank. Determine whether JKLM is a rectangle using the distance formula. Cool. Love the distance formula. So, Did I put another one? No, I did not. So there's two ways to go about it. Well, there's a lot of ways to go about this. Let's check that real quick. So I'm going to walk you through each of them. Option 1, you can graph this in GeoGebra and measure the angles to see if they're 90 degrees. Or you can measure the diagonals and see if they're congruent. Option number 3, you take the easy way out using just this graph. So for me to take the easy way out using just this graph, they say they want us to use the distance formula, which is, all fine and dandy, but quite frankly, I don't like the distance formula. So what I'm going to do is I'm going to measure the distance from K to M using Pythagorean's theorem, and then I'm going to measure the distance from J to L using Pythagorean's theorem. So Pythagorean's theorem, if we remember correctly, is a squared plus b squared equals c squared, where a and b are the legs of the triangle and c is the longest side or the hypotenuse. So the first triangle I'm going to do this to is going to be from J down and then over to L. So my side lengths here are 5 and 5, meaning if I use Pythagorean's theorem, I'm going to do 5 squared plus 5 squared equals c squared. So I'm going to end up with 50 equals c squared. Now I'm not going to take the square root of that. I know it's going to be about 7, but I know it's also going to be a messy number. So I'm going to double check this, and I'm going to check the length of km using my same method. So I'm going to switch colors. I'm going to go to this orange is too close. Those are too close. We'll go with purple. So from K to M, I'm going to drop a line straight down and then straight to the left. So I have side lengths of 1, 2, 3, 4, 5, 6, 7, and 1. So Pythagorean's theorem for this triangle would be 1 squared plus 7 squared equals c squared. 1 squared is, of course, 1 plus 7 squared, which is 49. So I would have 50 equals c squared. So I know that these, in fact, are the same length based on this, because if I do the square root of 50 2 times in my calculator, I'm going to get the exact same thing both times. So that's kind of the cheater's way. The more cheater's way would be to use GeoGebra. That is the way I would recommend. But you can also check it this way. And if you weren't sure if these were in fact parallel or not, so you weren't sure if it was a parallelogram, you could do the same thing we did back in, I believe, 6-3, where we went. So I went right 2, down 6. On this one, I went right 2, down 6, which means these have the same slope. Now that slope is -3. And then I would check the bottom and the top as well, which I'm going to go right 3, up 1, which would mean my slope is 1/3. And I would go right 3 and up 1 up here, which would also be 1/3, meaning that we have 2 opposite lines with the same slope, making them parallel. So I have 2 sets of opposite parallel sides with diagonals that are congruent. Or you could use GeoGebra. So this one you will do on your own by whichever technique you would like. I would, of course, use GeoGebra yet again to graph this because that's easier. So you'll do that on your own during our Zoom. And that's all we're doing for this. So have a great